All right, ladies and gentlemen, hello and welcome back to the only coast to coast show all about the information economy. It's time for Inside Analysis here at We Make Future in Bologna. And I'm with a very, very special guest today. We have Alberto Sangiovanni-Vincentelli. He is quite the accomplished designer. He focuses on teaching and on design, first for microchips and then later for planes and air conditioners and all kinds of fun things. And he's quite the data scientist. So you might call him the original data scientist, the OG data scientist. He's been doing this stuff a long, long time. And he's with us today. Alberto, thanks so much for your time today. What a crazy world we live in these days. Thank you
Yes.
for all your hard work. First of all, it's amazing to think how far things have come. And of course, you helped found Synopsys and Cadence, two very successful companies now. What are you working on now, and what do you think about these large language models shaking up the world of commerce and of human life on Earth?
Yeah. So right now I'm working on a variety of topics. I really like to look into several important problems. I enjoy researching new things, but in particular, now we are looking at how to use um, call it AI, but really more appropriately machine learning
Hmm.
for design, since this is my forte. And I have a particular view about artificial intelligence, machine learning,
Mm.
uh, because as everybody probably knows, these models are statistic in nature.
Right.
And so while the form of the language is very, very good, the content is not always right. And it cannot be. I mean, it cannot be, especially if you ask to something that is going to predict the future, then, it has to do with what it knows, which is whatever has been done in the past, as we
Mhm.
also do. And so the extrapolation is iffy. So there are people who believe that this large language model or in general AI cannot be wrong, but actually it is wrong.
That's
And
right.
it cannot be otherwise.
Right.
Poor baby, it cannot do what is impossible to do. But it's certainly a very powerful tool. So we do know about hallucinations, right? So things that are made up, but of course they are made up because, again, the nature of these models is stochastic. And so if you extrapolate, you have to take the consequence of this
Right.
extrapolation, which,
That's right.
is not always right. So it hallucinates. And so I love to see the progress of the large language model asking about myself. First time, this was at the beginning of ChatGPT and Gemini and the like. I asked about myself, and turns out that I won the Nobel Award, which is very nice. Is the first case of a Nobel Award given by an AI tool,
That's
but
funny.
you can see also how these models work because it works on probability. So since I didn't win a particular award, which is
Right.
called the Frontiers of Knowledge Award, and it's called Nobel Predictor, because many people who won that award ended up winning the Nobel Award. And so I think that ChatGPT say, poor guy, I mean, everybody wins it. Why? So he must have won it. So here goes. And also sometimes now the latest version of the languages ended up saying that I won an award that does not exist. I mean, it
Right.
just made up not only the fact that I won it, but this award existed.
That's
Just
funny.
amazing. It's very funny, actually. And so anyway, but this just to tell people, watch out, and to tell people, verify on something what kind of mistake it can make. Now, of course, the situation is improved dramatically with all kinds of guards, and the models that have been used are validated by the sequence of information that they get from the internet or from publications. So you can trace back where this information comes from. and which gives some more credibility to what happens. But it's important that people realize that not all that is said is true. In addition, they have to realize that by the way in which their answers are constructed, they, in the end, if you keep on asking and digging deeper and so on, what happens is that it will form an opinion, quote unquote, of what you want to hear, and
Right.
then it will tell you what you want to hear. So
Right.
which is also very dangerous because
That's right.
for young people, you may end up having serious situations in terms of depression. Even sometimes they claim that these models have an effect on suicidal thoughts and all of that. But again, it is intrinsic in the way in which they work. It's not that it's a bad guys or bad tools or whatever. It's the way it works cannot be otherwise
Right.
because you
But
build answers out of what you know has been asked or what you as a asker
mhm.
are all about, and so it will fit you.
Right.
So anyway, but in design, the interesting thing is that what we're trying to do also with this company, which is Cadence. I'm still on the board after almost 40 years in which I started the company.
Wow.
But what is important to see is that I can use machine learning and these models to explore the design space. So say, what if I do this particular design?
Hmm.
And then, you don't take it for granted. So then you verify if this design is correct or not. But the interesting thing is that you may have not thought of that design.
Right.
And so the tool is actually going to be very useful to suggest you look into something. But
Hmm.
then don't trust it. Just,
Right.
okay, wait a minute, let me verify if this is good or not. And what you do when you are in that situation is that you use the standard models or what we know about the physics of the phenomenon or the physics of what you're trying to design and use that to validate. So
Hmm.
then you eliminate, at least you try to eliminate the possibility of making mistakes. So it's a combination, right, of
Hmm.
what we know from a scientific point of view and what we can do with these powerful tools, which I think is the best way to go about it.
Yeah, and
And
you're making a very, very good point, which I'll talk about today at my speech at the We Make Future conference, which is that these models are excellent for discovery, for stochastic purposes, but they are not to be used as a system of record. And so you need your systems of record, like your old systems, ERP, Enterprise Resource Planning, supply chain management, for example. Those are your systems of record. That's the reality. And then you use these large language models to help explain things, to explore ideas. They're very good in that regard, but you should not use them as a system of record, right? Use them only for exploratory purposes and to generate text that you will then vet. Is that right?
absolutely, I mean, this is my recommendation. I'm not so sure that many people agree with me, but that's the way I use it.
Yeah. Well, that's very, very smart. So what are you working on these days?
Yeah, so this is one. So how you use machine learning in design, and with this contrast of physics, what we know and what we try to explore. And I always say, don't throw away the baby with the dirty water. So I mean, if you know something, why do you give up on that knowledge and
Right.
you try to rediscover something that we know, right? Scientifically, no. So don't try to recover the Maxwell equation because I don't think that any large language model will be able to recover it from scratch. But they are very useful to analyze and design things, right? So we use that and keep the models that we know are based on fundamental laws of physics.
Hmm. Yeah.
And
So
so that's what I'm trying to do right now. So and also I'm very curious about the existence of alternative model to the basic model that is used today, which is neural networks. And in particular, in large language model, is used feed-forward neural networks, right, which are very crude approximation models. And we compensate the relatively low power of a single component with gazillion components, right? So
Hmm.
in some sense, I don't like that as a concept to use brute force to solve a problem. So I'm always in love, being Italian, I'm in love with elegance. Right? So I like to think that there is a more elegant way to go about, exploring solution space and all that. So it, we don't even know why these large language models work. So in fact, there was Dario Amodei a few months ago ended up saying we know only about 3% why this large language model work.
Wow.
And the rest 97% we don't really know, which is, in my opinion, is absolutely correct. So there is no mathematical system that will explain the behavior of this large language model. And actually, if you look back in history, because again, artificial intelligence is an old concept, right? It goes back before the Second World War, and the Turing test for machine intelligence dates back to the Second World War. So I mean, people have interrogated themselves about the potential power of computing machines and how you differentiate that with respect to human intelligence.
Hmm.
But the key point is that I want to understand why things work the way they work. So,
Right.
and if you have this very large model, you ask, why are they accurate? Because they are. I mean, in several instances, I would say for certain fields, and I would say 80% of the times they're right. So where does this power come from? And if you look at, again, looking back in time, there is a Russian mathematician called Vapnik, and he proved under many conditions, but that the machine learning approaches or models that generalize the best. Generalize the best means that are giving you a right answer to a question that the model has never seen, right? This is a generalization
Mm-hmm.
capability of a model. Actually, the simplest models are the ones that have more power of being right on a question that has not been asked before.
Hmm.
And what we are doing is exactly the opposite of that. So it's very surprising. So
Hmm.
we are going by, with numbers instead of structure. So my question is, suppose that I build up another approximation model instead of being the node, the neuron, right? Let's call it neuron, but it's a distant model of how our neurons work, but
Hmm.
call it neuron. Okay. Is there another mathematical function that I can use besides the ReLU? ReLU is a typical function that people use as an approximation of what a neuron does. Because if that is the case, then maybe that we can build models that are less error prone, more elegant, and consume less power, and they are more compact and all that. But we don't know yet. I mean, it's people have gone down the path of minimum resistance. So
Hmm.
this simple model, and every time something is simple, people like it. So these simple models are powerful. So why try something else? But this is contrary to science, right? So anyways, so that's what I'm working on. I'm trying to work on. So these topics. One is to apply whatever we got with the large language models to explore the design space,
Mm-hmm.
but combine it with physics. And the other one is to try to understand what is intrinsically the power of this model. Where does it come from?
Mm-hmm.
What is the reason why this work the way they work?
That's amazing. So I think what you're saying is that small language models will probably be more effective simpler models because we have these incredibly complex large language models that even their creators don't know how they work. Well, if you don't know how something works, it's hard to fix it, right?
Right, exactly. Yeah, well, you fix it by looking at the behavior, right? So you observe what
Hmm.
this thing does without knowing what is inside. And then you uh, create a sort of guardrail around
Right.
this to try to fix it that way. So you fix it from the outside.
Well, and maybe one last point to dive into a bit. What really blew my mind when I was researching how they work is the fact that it is just tokens, and a
Yeah,
token is not a word. I mean, the word the could be a single token, or cat, or dog. It's small enough, but a
absolutely.
longer word is a bunch of tokens. So
Exactly.
it's not even presenting you a semantically correct sentence. It doesn't know semantics. It just
Exactly
knows
right.
the probability of this letter being next to that letter, which is like, what?
Exactly.
Like,
Well,
how?
it's a syntactical approach, right, to things, if you like.
Yeah.
But, this is a long debate that dates back to Noam Chomsky and other people in linguistics,
Hmm.
because the Noam Chomsky camp says that there must be a way to explain how a language works. So
Wow.
the origin of language and all that. So I can understand language by knowing the first principles.
Yes.
Now, that has not yielded very good results in terms of use. It's very interesting results in terms of the general theory of languages, but
Right.
it's not been really applied. And then there is the other camp, which is the stochastic approach to natural language understanding and manipulating. And that's
Hmm.
what we use today,
Yeah.
because we have the power to do it, because we have the chips, right? And the
Mhm.
chips were the GPUs. And so it's so amazing that GPUs are very good at the basic operation of a neural network model. So there is this link, right,
Hmm.
between the model and the chip that execute the model.
That's
And this
very,
is the strength of today's approach, is the fact that you have the capabilities of using these very large, complex things, because you have the chips that sustain that computation. But the chips themselves, now, of course, they have been optimized and changed somewhat, but they originally, the GPU were called graphics processing unit. And why
right.
graphics?
That's
Because
right.
they were used for rendering images.
Right.
And because the basic operation in both cases is sum of products.
Yeah.
And so they are very effective at doing that. And so how lucky can you be?
That's funny. I often joke that we should thank all the gamers because they created a market for the GPUs, which then opened the door to AI. So thank you, gamers, for creating a market to do all this stuff. Well, I guess the final question I'll ask for you is, well, you've already given some excellent advice here. I remember, I don't know if you ever studied the philosopher Ludwig Wittgenstein. A
Oh, sure,
German.
Wittgenstein,
He
sure.
wrote,
By the way, I did a classical lyceum, which is equivalent to a
wow,
bachelor in literature, I mean in humanities. So
nice.
anyway, so I know about philosophy
So you
somewhat.
know, right? So Wittgenstein wrote the Tractatus Logico-Philosophicus, which is kind of like the foundation of large language models, really, right? Because he broke it down mathematically, what can be said. I
Yeah.
mean, it's not exactly the same, but it's kind of interesting that he saw back then what can be said. And then, of course, at the end, he says, of that which we cannot speak, we must pass over in silence, right?
Yes, indeed, indeed, indeed. But if I look at some of my results, really have roots in philosophy. So I thank my philosophy professor because he gave me some basic knowledge about the philosophical approach to things.
Right.
And what I've been, in the end, when you grow old, you try to understand what you have done all your life, right? So you look back and say, what have I done? And you distill, right? And you
That's
create a
funny.
theory, right? So anyway,
That's good.
and I found out that everything that I've done and can be done in science of design is what I call meet in the middle approach,
Mm.
which is interesting because in this sense that if you look at what people do in general, they do either top down or bottom up. So top down means I have an idea and then I try to refine it until I come to a realization of this idea.
Hmm.
And this is called top down. So idea to implementation. But there are many people that do from implementation to abstraction, if you like, to a function. So a new function comes along that you want to realize. You get what you have and you modify what you have. And
Hmm.
so this is a bottom-up approach. But now, if you look at the view of the world by Plato and Aristotle, is Plato is top down, and Aristotle is bottom up. I mean, it's just amazing. So what I proposed is essentially combining Plato and Aristotle.
Nice. Meet in the middle. Meet me in the
Meet in the
middle.
middle.
Yeah.
Exactly right. So if you
We'll
look at
all
my
get along.
publication, right, you will see, and I theorize that and so on. Well, anyway, but
Perfetto.
it's amazing,
This is
if
amazing.
I must say. Mm.
Well, ladies and gentlemen, look this gentleman up online. He's on LinkedIn and he's at Berkeley as well. Alberto Sangiovanni-Vincentelli. Grazie mille.
Grazie.
We'll be
Bye,
right
Eric.
back. You're listening to Inside Analysis.